Okay, so I gave you this function that find the derivative of f of x is equal to sine x from first principle. And from first principle, you know the formula is f prime of x is equal to the limit as change in x approaches 0, f of x plus change in x minus f of x all over change in x. So this is the formula. This is the formula for the first principle. And our function given is what? F of x is equal to sine x. So now we need to find f of x plus delta x from this function. And I've already shown you how to find this from this. So simply, our f of x plus delta x is going to be sine x plus delta x. So this is what we have. But we can expand this expression using the identities we know under trig. Then afterwards, we just do substitution into the formula. So from trig, we know that whenever you have sine a plus b, is the same as sine a cos b plus cos a sine b. Is that okay? So we are going to use that same ideology here to expand f of x plus delta x. So our f of x plus delta x becomes sine x cos delta x plus cos x sine delta x. So we have a nice expression for our f of x plus what? Delta x, which is the whole of this. So we move on to substitute f of x and f of x plus delta x into our first principle formula. So our f prime of x becomes f of x plus delta x. So we write our limit as delta x approaches 0. So we know the f of x plus delta x is equal to the whole of this. So we write this expression in place of f of x plus delta x. So we have sine x cos delta x plus cos x sine delta x. Then from the formula we have minus f of x, and our f of x is what? Sine x. So minus sine x all over delta x. So delta x. Good. So we move to the next step. Write limit as delta x approaches 0. So from this expression, what we are going to do is we can factorize, because I have sine x here, sine x here, so I can group the signs together. So I'm going to have sine x cos delta x minus sine x, then plus my cos x sine delta x. Please don't forget that x and delta x are different. They are different variables. So we move to the next step. So I have limit as delta x approaches 0. So from this part, I can factorize sine x out. So I'm going to have sine x, then bracket, cos delta x minus 1. Then I have cos x sine delta x. So all over my what? Delta x. That's the change in x. So this is where we are. So I can write this whole expression as, so I write my limit as delta x approaches 0. So this whole expression can be breaking like sine x cos delta x minus 1 all over delta x plus cos x sine delta x all over what? Delta x. So we move on. We are not done. We are coming to apply the limit. So looking at this is limit of this function plus this function. So I can apply the limit on this plus then I apply the limit on this. So that's what we are going to do in the next step. So our f prime of x is equal to limit as delta x approaches 0 of what? Sine x. We are taking this one first before we move to this. So of sine x to brackets cos delta x minus 1 all over delta x plus limit as delta x approaches 0 of cos x sine delta x all over what? Delta x. So this is what we have. So looking at this, see the limit is just affecting the limit is what? As delta x approaches 0. So since sine x here does not contain any delta x, I can send it out. So I'm going to write this like sine x limit as delta x approaches 0 of cos delta x minus 1 all over delta x. So it's going to be sine x limit as delta x approaches 0 of cos delta x minus 1 all over delta x. And this one to cos x, since it does not contain any delta x, I will bring that one to out and I get lim delta x approaches 0 sine delta x over what? Delta x. So we are not done. We are now coming to apply the limit. So looking at this point, you see delta x is approaching 0. So when I substitute 0 here, it's going to give me cos 0 minus 1, which is going to be 1 minus 1, 0, and here will be 0. So 0 over 0, indefinite. Looking at this one too, when I substitute delta x is equal to 0, you are going to get sine 0, which is 0, over 0. That one too is indefinite. So we will apply the L'Hopital's rule. What I taught you yesterday, the L'Hopital's rule, to evaluate this limit and this limit. So for this, what you are going to do is you pick the numerator, differentiate separately, and you differentiate the denominator separately, all with respect to what? Delta x. You do same to the sign. So you differentiate sine delta x separately with respect to what? Delta x, and do same to the denominator with respect to delta x. You are differentiating with respect to delta x because the limit is what? Delta x approaching what? 0. So we differentiate with respect to delta x. So I have sine x limit as delta x approaches 0. So when I differentiate cos delta x, I'm going to get minus sine delta x. And when I differentiate 1, I'm going to get 0, because we know that when you differentiate a constant, it's equal to what? 0. So I come to this. When I differentiate delta x with respect to delta x, I'm going to get 1. So we are done for that part. We go to the second term. So cos x limit as delta x approaches 0. So when I differentiate sine delta x, I'm going to get cos delta x all over. And when I differentiate this, I'm going to get 1. So we are done. So it becomes sine x limit as delta x approaches 0 of minus sine delta x plus cos x as times the limit as delta x approaches 0 of cos delta x. So now we can apply our limit nicely. So I have sine x. So this is the limit as delta x approaches 0 of minus sine delta x. So I'm going to substitute delta x is equal to 0 into this. So I'm going to have minus sine 0. So plus cos. And this one too, I'm going to substitute delta x is equal to 0 here. So I'm going to get cos 0. And sine 0 is equal to 0. And cos 0 is equal to 1. So my answer becomes 0 plus cos x. Therefore, f prime of x is equal to cos x, meaning whenever you differentiate sine x, you get cos x. So we are going to glance through again. So this is the function given, sine x. And from the first principle, we know that the first derivative is equal to limit as delta x approaches 0 of f of x plus delta x minus f of x all over delta x. So from the formula, we have our f of x. We just need to find what? F of x plus delta x. And since I know that f of x is equal to sine x, my f of x plus delta x is simply going to be, I go back to my f of x. Wherever I see x, I put what? X plus delta x. So it becomes f of x plus delta x is equal to what? Sine x plus delta x. So using the basic identities in trig, like the expansion of sine a plus b, and this is it, I can expand this using that same ideology here. So this is what we have for the expansion. So you just do substitution into your first principle formula, and when you do that, you are going to get this. So I grouped the one with the sine x together here, and I have my cos x sine delta x all over delta x. So I can factorize sine x out from this side, and I'm going to have this, and I repeat this term. So that's what we have here. So from this, I can say that this over this plus this over what? This. So that's what I've written here. So I went further to say that limit of this plus what? Limit of the second term. And since the limit is just affecting delta x, I can do what? Send the sine x out and apply the limit on the terms containing delta x. So I did same here. And looking at this, when you apply the limit, this will be 0 over 0 and this will be 0 over 0. So they are indefinite. So we need to apply the L'Hopital's rule. And you differentiate this separately. You do same for this and this. Then you apply your limit. So when I differentiate cos delta x, I'm going to get minus sine delta x. And minus 1 will give me 0. And this one will give me 1. I did same here. When I differentiate sine, I get cos. I differentiate this, I get 1. So I did it, and this is what I have. So you just apply your limit, and we are getting what? Cos x. So that's the derivative for sine x. And this is the process using first principle. Thank you.